Hello everyone, welcome to my CCI Enterprise course. In this course, you will learn all the technology related to your CCI Enterprise journey. And in case if you are looking for the actual lab type of scenario and the solution, then you can reach out. You can send me email Ratnesh721 Kumar721 that is here, and then I will send you that detailed info that how my students they are preparing for their actual lab training. It will be almost similar that what you will expect in the exam. You can practice. I will help you. I will guide you for 1 month to clear this exam. I will help you step by step how to drill down um, the solution, drill down the technology into small pieces, and I will help you to pass your exam in first attempt. So go for this course. This will be a good place where you can learn the technology. But if you are serious about the CCI lab exam, then you can drop me an email and you can get the detailed info. All right, so let me stop this video, and if you watch this video, you can simply contact me and you can get the information related to the new update that we have in the CCI Enterprise Lab. So what is MPLS? MPLS is multi-protocol label switching. So what does it mean? Is it mean that while routers they are forwarding packets, they are using switching technology, or do we have a separate routing table and do we have different or separate forwarding table? So we are going to understand about MPLS label switching. Okay. Now, interesting thing here is this that MPLS is industry proprietary, and later on in this section, I will show you that there is one terminology called Cisco Express Forwarding, that is the CIF. So the idea behind either it is MPLS or Cisco Express Forwarding. So this was Cisco proprietary, and MPLS is industry standard. Obviously, the MPLS taken from Cisco CIF technology, means Cisco was using earlier, and then you can think as enhanced version we are using or modified version we are using inside MPLS. So think like this, suppose if you have multiple routers, so many routers that ISPs have, and while you are running any type of protocol, any type of interior or exterior protocol, the problem here when these routers, they are taking the router decision or routing decision, they have to scan, they have to check their routing database, whatever entries they have in their routing database. So maybe they have 5,000 entries. They have to go and scan 5,000 entries, and then they have to take the best out of it. So doing this, what will happen that not only the routing process, so obviously the routers, they will use their routing process. That means the software cycles will use. Apart from that, they have to run that or rerun that algorithms all the time related to routing. So that cycle will also get to use. So that means in turn that time is there, means time lagging will be there because you are taking the decision based on the routing, or all the time you are taking the decision. Suppose if you are building or rerouting the traffic from one location to other location. Okay. Now, this term has been eliminated from this routing decision, and the solution we have in terms of MPLS. So what MPLS is doing is that instead of building the table, instead of building the decision table, instead instead of taking the decision based of routing entries, they are taking the decision based on labels. So suppose if you have 20-bit label, so all the routing entries that we have, and again, that is belonging to MPLS. So where you are using the MPLS network. So what does it mean? It means that suppose I have big routing infrastructure. In this big routing infrastructure, I'll go and enable label switching. So inside that, I have so many routers who understand, who are building their label tables, and according to that label, the routers they are taking decision. But outside this, or maybe coming inside this, you do not have MPLS. Here you don't have MPLS. Here you don't have MPLS. So that means at location one and at location two, you are taking decision based on IP routing. So these may be customer network, these may be transit path, where the decision purely based on IP tables. But once you go and enable the MPLS for organization, suppose if you're ISP, so inside that organization, inside that specification, inside that private zone, you can think that the decision has been used with respect to labels. Correct. And again, labels can be imposed. And again, we'll see in upcoming sections, there are various parameters, things that we will learn in upcoming sections. So you can impose a label based on destination IP, source IP, QoS parameter, VPN destination, outgoing interfaces, layer 2 circuits. Okay. So this is the MPLS technology. Means first point is this, that it is taking a decision based on the labels. So that's why the software cycle or CPU process utilization will be less. Now, the other very important thing that is derived from Cisco Express Forwarding is this, that suppose if you have router, obviously you have a routing process, RP inside that. So first time the router is taking the decision, and then they are telling this information to the software process. Correct? So all the time, whenever the entry will come, it will not take the decision, although next time routing will not happen, next time switching will happen. Okay, so first time we have done the routing, next time we have done the switching. That's the core idea behind the MPLS. Okay, so what we are going to do in the next section, I will go and enable the MPLS inside few of the routers, and I will show you that how these labels look like, how the basic decision formation happening, and then we'll go and learn more and more about the MPLS labels and other technical stuffs. In this section, we are going to perform a small lab task, and we are going to understand about MPLS labels as well. As we know that MPLS is purely based on label switching. So in this section, in upcoming videos, we are going to dig deeper inside how the label switching working. Let's understand that what type of labels we have, means what are the fields we have inside the MPLS label. So here you can see that first of all, the label is of 20 bits, and I'm going to show you in the lab that these numerical is the labels are numerical, and how they look like, what's the range, etc. Then we have 3 bits, experimental bits, and basically Cisco is using as a IP precedence for the COS markings. We have bottom of a stack as well. That means if you have multiple labels and this bottom of a stack bit set to 1, that means this is the last label in that marking. We have 8 bits of TTL, time to live, as well in this particular MPLS label field. Apart from that, you can see that for unicast packets, we have the hexadecimal number 8847 in the label, and for multicast packet, we have 8848 just to identify the packets. All right. So let me quickly go and show you the blog side where we have the basic lab. First of all, we'll do the basic lab, and then in the upcoming sections, I will go and cover more and more theories. So here you can see that in my blog side, I have created chapters. Actually, total chapters you'll find 1 to 11. So let me go to the bottom. Let me show you how many are there. And I'm going to cover each and everything, and I will show you the references as well. So while you are doing your study, you can go and find these important references. So starting with the basics, you will find the lab is also there, and the same lab as well I'm going to cover in the upcoming section. So let's just start with the first chapter. What is the agenda for MPLS chapter 1 in this section is just to understand 2 things. Question number 1 in form of question. So what are the command to enable MPLS to the routers? Then how to verify that the local label a router had chosen for a given network means you have to go and enable the MPLS, and how you can go and check the MPLS levels over that router. What are the CLI commands? So here you can see one of the lab topology. I'm going to use the same one in our lab as well. Let me use the pen here. So you can see here that you have router 1, router 2, router 3. Same, I'm going to take router 1, router 2, router 3, same type of network, subnets and loopback as well. And I will also go and enable the OSPF inside this small network. And then we'll go and verify. So first of all, you have to go and enable MPLS IP. If you go and enable over the global, that means for all the interfaces, you are enabling the MPLS, but we can go over the certain interface and we can give this command MPLS IP. That means that these particular interfaces, so suppose R2, this fast Ethernet 00001, we want to enable this. So we can go to those interfaces, give the command MPLS IP, and this will be enabled. Once it is enabled, then we can go and verify certain CLI commands. Again, about LDP and labeling protocols, we are going to discuss in the upcoming section. More and more we'll understand about this. So let me quickly show you the basic commands, how to enable MPLS over the routers in the lab. Let's see the interfaces. So I can go here to router interface gig 0/1, and I can go and give MPLS IP, correct? Likewise, you can see in the diagram that router number 2, both the interfaces are part of MPLS. So I can simply go to the global mode and I can enable MPLS IP. Then I can go to router number 3. Router number 3, one of the interface having MPLS facing interface. You can see here the diagram in the blog. You can see router 1, router 2, and router 3. So once we have that enabled, then we can go to the router number 2 and run some verification commands. So I can type enter here. I can go and check show MPLS, and you can type question mark. You can see various options are there. LDP, and with it LDP, let's see that what options we have. So you have the neighbor. You can go and check the neighbor. You can go and check the bindings as well. And basically we want to check the binding. So show MPLS LDP binding, and that binding we want to check for which loopback. So suppose I'm in router number 2, I want to check router number 1 and router number 3 loopbacks binding. So we can go here and we can see here binding say 111132. It's telling that lib not enable. Okay, so that means here you can see that I should go and run this lib. So this is the command that you can go and run MPLS IP and it should work, correct? But it is telling that lib is not enabled. Now, one very important thing here is that while you are enabling MPLS, you should have your routing, unicast routing protocol enabled. So let's see that we should have, you can see I'm getting 111, I'm getting 333. That means my unicast routing is working. So I should have my MPLS working here. You can go and check gig 0/1 in router number 2 and gig 0/2. I have run this over the global interface, but I am not seeing enable over the physical interface. So you can see I am now doing MPLS IP over the physical interfaces, and now I can see the messages. So you can also see that MPLS now it is showing here. I can go press up arrow just to check the bindings, local bindings, and here you can see that we have the local binding. So here you can see the label starting with 16 and then the remote binding. So yes, router number 2 has 2 bindings. Now why this is null, why this is 16, we'll go and understand later on. Okay, likewise if I go here and if I check with respect to 3.3.3.3 32. So here you can see local binding is 17, and then you can see the labels for the remote binding, correct? Now we can go parallelly and check the MPLS forwarding table. That's a very nice command that we have. How we are reaching to 1.1.1, and then how we are reaching to 3.3.3.3. So IM router 2, how I'm reaching to 1.1.1, and while reaching there, how we are popping, we'll understand that uh, what is label imposing, what is label uh, swapping. All those terms we are going to understand. So in upcoming section you'll come to know that when the labels are get attached, when it is detached, when we are doing swapping, when we are doing popping, all these things we are going to understand in upcoming section. But obviously, suppose if you are the last hop, so the last hop router means, suppose if you are the destination, the last hop router will remove the label and then it will send to the destination. Now if we are the incoming packet, okay, means you are going to go inside the MPLS domain. So what will happen that the router will impose the label, correct, and then it will send. So what will happen, suppose if you have enabled MPLS here, if traffic will come, so this router will put some label here and then it will send here. Then this router, suppose it is checking label 17, it can swap the label with 18 and then it will send to the next hop. Then it will see, oh, 18, and this is my final hop, so it will remove the label. So label will get attached here, then label will get swapped here, and label will get removed here, correct? So this process will continue along the path. Okay, so this is the way that you can go and enable the MPLS label. You can go and do the baseline verification as well. And final thing, you should check that what about the safe entry. So again, you can go and check the safe entry related to 111 if you want, and you can go and check the safe entry related to 333 as well. So simply it is telling the next hop, what is your adjacency, what is the physical path along which you are sending the packets. Let us continue and understand more terminologies related to MPLS. So as we know that in our day-to-day activities in our infrastructure, we know that our routers, that to whom we are managing our routing table, to whom we are running our routing services, they are nothing but the customer edge. And when these customer edge, they are connected with ISP, so suppose ISP1 and ISP2, then if we go inside the ISP, suppose I am inside ISP1, so this CE is actually connecting with PE, provider edge. So your CE, your customer edge routers, they are connecting with provider edge, and this provider edge, basically they are connecting with the core routers. They are termed as a provider routers. So CE going to P going to P, or the provider. The same nomenclature you have in MPLS, like LSR, they are working as a core, means they are the core routers responsible for these MPLS packet forwarding, or the label forwarding, you can say, but they are working as a core. So they are forwarding the MPLS labels. Then we have the edge. So edge routers, they are PE, they are termed as a edge LSR, and basically they are adding or removing the labels. So when the customer traffic will come, they can mark the label and then they can forward to the provider. Or if the traffic is coming, or the return traffic is coming, again they will go and remove the label and then send to the customer. So marking the label or removing the label, that's the responsibility of the P router or edge LSR. Then we have the non-label routers, that's the customer edge or CE devices. Okay, again, we have the control plane build up, we have the data plane build up. More I will show you in the upcoming section in the block side as well. But yeah, control plane will go responsible for routing and label tables. So routing tables will be there and different type of tables are going to form. We will understand more and more in the upcoming section. And then we have the data plane who is going to forward the data based on the label information. So next hop label, what is the next level I have to reach? Because this data plane information or data plane decision is happening hop by hop or label by label. Okay, so that means in turn that we have the routing table. So any routing protocol or domain, they will form it. But again, you have routing in your CE, then you have routing in between CE to PE, and then you have routing from PE to P. So different routings, and where MPLS, where BGP, where IGP, these are fitting, you will see in the upcoming sections. When we have one big lab where you will find C, P, and P, you will understand that how everything will fit into the picture. Okay, then we have label table as well. So that means that we have two different type of tables. One table is related to routing, and once you have the routing table up and running, once you have end-to-end reachability, then label table will come into the picture. Then again, we'll see that with respect to label table, what type of protocols are into the picture. So we have two protocol. One is LDP, one is TDP. LDP is label distribution protocol. That is industrial standard. Then you have TDP, that is tag distribution protocol. That is Cisco proprietary. LDP. Now default Cisco devices, they are using TCP port 646. In the lab, we'll explore more on that. And Cisco proprietary TDP, they are using TCP port number 711. And mostly we are going to use LDP. So if you go to the routers, if you enable MPLS IP, and suppose if your underlying unicast routing is up and running, so they will go and form the LDB table. Okay, and we can go and verify as well. I will show you that how we can go and check the LDP neighbor table, LDP tables, etc. Okay, so MPLS is going to form different type of tables, and where and exactly what point they are forming what table, I'm going to show you in the diagram as well. But we have at least two table. But again, we have other table as well. Say we have RIB table, routing information base. Then we have FIB table, that is the safe forwarding information base. And then we have the actual dynamic table, that's the label forwarding information base. So whenever the packet will move, they will see what is the next level, what is the next level, what is the next level, and the packet will move. Okay, so I hope you understood this basic terminology. What I will do, quickly we'll go to the blog side, and inside the blog side, I will show you one of the lab, and we are going to cover few of the questions, few of the answers related to the chapter MPLS chapter number 2. So you can go to this blog site, you'll find MPLS chapter 2, where we have to go and answer these 4 questions. Question number 1, what protocols port are used for LDP hello session? As we have discussed, the protocol TCP port number 646. So what is happening? Let me answer you one by one. So what is happening that first of all, they will go and discover their neighbors. So assuming that you have underlying routing protocol up and running, then these devices where you have enabled MPLS IP over the interfaces, they will go and send the multicast packet with 646 with this multicast address. Once they discover the neighbor, then they will go and create the TCP relationship with this particular port number. Okay, so question number 1, answer completed, that they are going to use the LDP is using the port number 646, and they're using TCP for reliability. Then question number 2 here, how does R3 know what R2's labels for their specific network? Now, how R3 is knowing that R2 is using such label or not? Okay. Again, what is happening that MPLS itself, they are forming the label relationship. That means that they have the label table. So all the devices, they will form the label. So they have the local tagging, they have the remote tagging as well, correct? And as per the tagging information, they have to forward the packet. Okay. So that means that R3 is only knowing how to reach to R2. Once it will reach to R2, then R2 will come to know that how to reach to R1. Like that, the label swapping and labeling position, label removal or detachment will happen. So the answer for this is that because you have the routing table, on top of that you have label table. With help of label table, with help of LDP label table, that label database tables that we have, they will come to know about the each other's level. So local level and the remote level. Now, what is the next question? When MPLS is enabled, what would prevent LDP neighboring? Now, LDP neighboring, who will prevent and how it will broken? That means if we have unreachability, suppose if routing is not working, underlay, suppose in between your filtering port number 646, some firewall, some access list rules are there who is blocking this neighbor to be discovered, this port to be blocked. There may be congestion in a network, so there may be loop in a network. So network related issues plus physical issue plus access issues can prevent to form the LDP neighbor relationship. And then final question here is that why would we are using ACL when using MPLS debug? Remember, this is common thing. We have discussed this earlier that whenever you are using debug, please use with care. Please use with certain restriction. Please use with exact sources, exact destination. Because if you use debug, this is intrusive and there are chances that your device may reboot or crash. So whenever we are using debug command, we should use with certain ACL, and that's why it is recommended here. You can see that we can go and form one ACL, either it is a prefix list or access list. You can form one ACL and then you can apply to the debug command. Okay. So like that, we can go and proceed. Let me quickly log into the device. Let me show you these configurations one by one. So first of all, what we can do here, we can go and check few of the things. So I want to verify the MPLS LDP neighbor, and then let's see. So here you can see R2 is knowing about R1, R2 is knowing about R3. Likewise, if you go to the R3 and if you go and run the command show MPLS LDP neighbor, you can clearly see the port numbers. So see, R3 is knowing that LDP ident local, he know about himself, he know about the TCP connection, he know about the remote and the local connections, okay, with help of LDP. Correct. Again, if you are in R3 and if you are looking for LDP table, LDP binding table, so you can go and check the bindings and you can check the all as well. And you can go and check local binding as well. Okay. So these are some of the basic commands we can go and verify, and we can check baseline configuration with them. Let us continue our lab, and in this section, I'm going to cover few more important interesting topics. We have some questions to answer. So for example, how does the IGP next hop affect the LSP? We have the switch path and how it is going to be affected. So one point we know at this point of time that in my domain, where I'm running my MPLS, once I have my up and running loop-free unicast network, on top of that, we can go and enable MPLS IP. That means we can enable MPLS, and then they will go and start building the LDP sessions. So that means that once I have the RIB table, then the lib table, label information base, will come into the picture. So that means that if I have break inside the RIB table, that means the break will be inside the lib table as well. Correct. And that's the reason you'll find that it is a prerequisite that you should have your RIB up and running. RIB up and running. Question number 2. Why does LDP advertise all local IPv4 addresses to a neighbor? We'll see that when we have the LDP, we'll go and run few verification command. We'll see about their label exchange. Uh, we are going to use some CLI commands for that. Okay, and then by default does LSP path. So we have the label switch path match the IPv4 path. That's quite interesting. And in upcoming session, I'm going to cover even little bit more about this, that how different type of tables means where exactly they are forming. Okay, so wait for the next video where we'll go a little bit deep inside that. But here also I'll cover that that what exactly happening in between the rib table and the lib table. Okay, what's the relation in between them? And finally, what is the liberal label retention? Let me go quickly open the blog side, and in the blog side where you will find these questions. So here you can see that you have question number 8, 9, 10, and I'm going to cover one by one all these things. But here also, if you go and read the blog, you'll find that some explanation was there. Only one thing I just wanted to highlight here. So suppose if you want to change the path. So here question number 10, by default does LSP match the IPv4 path? Now, LSPs, they are driven by the IGPs, Interior Gateway Protocol. And if you want to manipulate, then we can go and use some sort of MPLS traffic engineering. Since there are certain protocols we can use and we can change the path. We can do some sort of traffic engineering. Okay. So that's the one thing. Rest of the questions also you will find here the important notes highlighted in little bit bolder. So here you can see this is very important point. IPv4 control plane build. So IPv4 control plane, that is the RIB database that will be used to form the MPLS control plane. So IPv4 control plane is building MPLS control plane, and that's not exactly the case when we have the actual data plane with respect to MPLS. Okay, that may change, and if you want to do the changes again, there are ways that we can use traffic engineering, some other ways that we can force change these paths. Okay, so what I'm going to do here, let's go back in the lab that we have, and first of all I will show you that changing the next hop path, how it will affect. And we have to do some sort of debug ACLs in the previous section, that also I am going to cover here. Okay, then finally you will find the label liberal label retention. So there is one or two liner explanation about that. Okay, so here you can see the explanation. For a given router, the upstream and downstream labeling is liberal label retention. So here you can see the downstream, some labels will be there, upstream and downstream. That's just the term. Okay, all right, so let's go to our lab, and mainly we are focused on router number 2, where I want to create one access list. So let me create one access list 1, and I can do permit host 3333. Great. Now what I want to do here, I want to change the next hop. So to change the next hop, I can go and create one IP route. And before doing that, I just wanted to enable the debug as well. So I just want to enable debug MPLS LDP, and then you can see the bindings. You can see that you have prefix ACL, and the name of ACL is 1. Okay, now what I will do, I will go and create IP route, and this IP route is for the next hop, means the reachability for this prefix, that is a loopback network /32. And then the next hop, we know that to reach here you have 10.1.23 network, correct? But I'll go here and I'll make the next hop like this. That was wrong information I'm giving. And you can see here that we are getting lots of debug messages. So what it is telling, a prefix recurs, walk start, get path, labels, update, etc. Some problem is there. Now, if you go and check the, let's see here, yeah, show MPLS, and if you check the forwarding table with respect to 3.3.3.3. Let's see. And see here the byte count. So you can see that you have some problem here, and that's why the labels, you can see bytes label switched. So MPLS switch path LSP is having problem, and that's why they are getting counters here. If you get counters here, that means you have some problem. So clearly you can see that if you have a wrong wrong IPv4 path, then LSP path is also not correct. Okay, so that's the one important aspect here that we are checking. Okay, apart from that, I'm going to show you a few more verification command. So let me quickly go to router number 3, and few important CLI commands we are going to see. You can go and check the show MPLS LDP neighbor. You can see the LDP neighbor. Then you can go and check the LDP bindings. These are actually very, very important commands. And I want to check this with respect to my peer, that is 222.32. And then I want to check the MPLS forwarding table and 22222. Okay, so here you can see that we are checking first of all the LDP information. Who is my neighbor, correct? Now once we know that who are my neighbor, you can see clearly the neighbor entry is here. Once I know my neighbor, then I can go and check the LDP binding. Okay, so this prefix that we are checking, you can see the local binding, you can see that implicit null is there. If it is destination, obviously you want to remove the tag and you want to reach there. And then finally you can see the forwarding table. Now what is the relation between lib, fib, rib and all those interconnections? We are going to check in the upcoming section. Okay, in the upcoming video I'm going to show you that. Meanwhile, I just wanted to remove that command. So I will restore my MPLS. I just wanted to go here to conft and negate that command. Okay. So let's wait. Last DNS will get resolved, and then I'll go and revert back that. Okay. So conft and we'll go here. This is the command do no, and you'll see soon that they are forming the LDP relationship. When you can take a screenshot of this, and you'll find most of the important message related to debug we have here in this slide. All right, so let's stop here. This is quite important section where we are going to discuss very important topics related to control and data plane and different type of tables that RIB, that the routing and the MPLS they are going to form. Okay, so let's understand these topics because they are the core, they are the fundamentals understanding the MPLS technology. Okay, and even you can bookmark this particular video session and you can refer. So in future, if you want to refer, you can come and refer this theoretical section. So whatever we have studied so far, we have discussed different type of thing. Like we have discussed that we have something called label. We know that if we have a routing table built, we know that if we have loop free routing protocol, this routing protocol is going on and you have loop free network. Then on top of that, this LDP, the label distribution protocol, they will exchange their label and they will form their label information base, correct? So the order of operation is such that we have or we should have a routing in a first place. So you have your rib table, and then you will find that you have your label. I'll write here a rib and lfib, label based, or in Cisco we are referring as a tag based forwarding information base, or tfib, correct? But remember, earlier I told you that there are two different type of plane. One is termed as a control plane and other is termed as a data plane. And with respect to control plane and with respect to data plane, where exactly what type of information base, what type of databases are creating, that we are going to discuss in this section. Okay, so here you can see that different questions are there. First of all, suppose if you are getting the packet with unknown label, then what router will do, what he will do next. If you are getting one packet without any label, so we'll discuss about that what is PHP, penultimate hop, what does it mean. We will go and discuss about penultimate hop popping as well in few minutes. Then what is rib, fib, lib, lfib, cef, etc. You will understand each and everything related to these topics, and there should not be any doubt, any confusion. Then which is the preferred CEF, MPLS or IPv4 forwarding? So that also we will discuss in this particular section, and what are different type of labels we have in MPLS. So we are going to discuss each and everything in this particular section. Let me clean all these drawing. Yeah. So we have one table, and let me highlight that table here, and let me scroll a little bit down, and let me highlight the table first. So here you can see that suppose if you are a router and then you are getting packets, then what will be your forwarding decision? And that's question number 1, 12A, that if you are getting a packet without label, what you will do. Now suppose if it is related to IPv4, you can take the decision with respect to IPv4 engine. Okay, so the fib will come into the picture. Again, we are going to discuss about the fib, the lib, lfib, etc. Whatever you are seeing here written, we are going to discuss about that in couple of minutes. So IPv4 packets, if you have, means obviously unlabeled packet, if you have, you can send to unlabeled packet. Again, if you are getting something as a CE and then if it is going to PE, that means that IPv4 packet going to MPLS, so you can go and use, you can go and mark it as a tag or label. So IPv4 can go to MPLS. Then if it is a MPLS packet, obviously it can go to a next hop MPLS label, correct? And finally, it may be MPLS packet, but you are going to the IPv4 domain. So MPLS packet can go to the IPv4 domain, correct? So all these possible options we have, right? Great. So we understood now question number 12A. What about question number 12B? What is PHP? Now, as the definition says about PHP, PHP is nothing but penultimate hop popping. And what does it mean? So it means clearly is that this will be last, normally last hop must, means what is actually what is happening, and maybe you have seen this in the previous lab. We have seen one type of label called implicit null. So what does it mean? Now if this router knows that my last destination is IPv4 and my last packet is going to the IPv4 network, so he will not impose any label in this, because he know that the last hop is something that I don't have to push the label and send it, or put the label, send it. So that's why this PHP will come into the picture. So what PHP is doing, this is simply mean normally last hop must, looking, look up MPLS label, pop MPLS label, look up IPv4 destination. PHP avoid extra lookup on the last hop. Okay. Anyways, you know that this is my last hop, so why I will put the labels and then remove it. So better do not put any label or put the label as an implicit null. And that's the meaning of PHP, penultimate hop. Great. Now coming to the main question that we have today. And the main question is about all different type of control and data plane, different type of uh, engines or different type of information bases that we have. Okay, so let's try to understand that. I'm going to pause it here. If you want to take snapshot, let me clean the stuff. You can take a snapshot and let me continue from here now. So here you can see, first of all, with respect to routing protocol, you are forming something called a RIB, routing information base. Correct. Now, a RIB is inside the control plane, and what will be the data plane equivalency? IP to next hop, IP to adjacency, correct? And that is nothing but the fib. So you can see that you have a RIB to fib connection. Now, when MPLS is coming into the picture, so inside the control plane, you can see inside the control plane, they are doing something MPLS IP routing. We know that LDP will come into the picture, label distribution protocol, or TDP, tag distribution protocol. And here you are forming the label related database. That is nothing but lib. You can see lib or tib. In Cisco, it is tag information base. In industry and standard, it is a lib, label information base. So what we are building inside the control plane, in the control plane, we are simply building the rib and we are building the lib, correct? Now, what about data plane, where the actual packet will forward? So in data plane, you can see that the rib is building the fib, but lib is building the, and you can see lib is building the tfib or lfib, correct? Lfib is nothing but label based forwarding decision, or tag fib nothing but tag based forwarding decision. And that's the core of MPLS. That's why if you get the terms like this is happening in control plane, this is not happening in the data plane, so this is the reason behind that. Now, how we can go over the lab devices or over the routers and we can see different type of tables. So yes, you can go and verify it. Suppose if you are looking for a RIB, routing information base, you can go and run the command show IP, and let me highlight here. So you can run the command here. You can see that show IP OSPF1 RIB. It will give you the RIB table. If you are looking for lib table, label information base, you can go and run the command show MPLS LDP binding, correct? And let me clean this. And finally, if you are looking for LFIB, that's a dynamic, that's actually the table inside the data plane. So LFIB, we can check with show MPLS forwarding table. This is the command. Okay, so three different table. The RIB table you can see with show IP OSPF1 and RIB. Then lib table you can see with show MPLS LDB binding. And finally, the LFIB table, that's the dynamic table that you can go and verify with the show MPLS forwarding table. Now there are, so last question here is this, that in MPLS you have different type of labels used. What different type of labels you have? You have pop, means you are popping out the label. You have swap, you can make 10 to 20 swapping of the label. Push means you are pushing the table inside the frame inside the packet. Untagged means the stack is removed and the packet is forwarded unlabeled. No label or untagged means the packet is forwarded unlabeled. And then finally aggregate. Aggregate is the label stack is removed and an IP lookup is done on the IP packet. Okay, so again here also you can have a look and you can make your notes that different type of labels we have inside MPLS. We have pop, swap, push, untagged, and aggregate. All right, so I hope that this particular video lecture is quite interesting for you, and let me stop here. In 2.2, we have to understand about MPLS layer 3 VPN. And these sections also, this section and upcoming video also, you'll find that we are going to understand these with respect to questions. So we have few questions like 2 to 3 questions per section. And according to that, we are going to understand that. Apart from that, what I have done that for this particular section, we have lab as well. So upcoming videos, you'll find that we have full-fledged lab understanding that how CE to PE communication is happening and how PE to P, that's the provider. So provider age, customer age, how these routings are happening, and how different type of technology fit into the picture, such as what is a VRF, use of VRF in this particular lab section. Then you will understand use of VPN v4, use of MP BGP, where all those things will fit into the picture. So we are going to understand each and everything. But before going to the lab section, let's understand a few of the terminologies. Those are very useful for our lab section. So let's check the question number 20, 21, and 22. First of all, what is layer 3 VPN and what does it mean by sharing the routes between customer and the provider? Okay, then why does we are using VRF, virtual routing forwarding instance, and what's the use of it? And then finally, what is the protocol being used in between different PEs? Okay, so let's understand one by one. First of all, what is layer 3 VPN? And you will understand this with respect to this particular diagram. This is our lab diagram as well. And you'll find that you have CE routers. Now, suppose this is the service provider in the green, and this service provider may have to deal with multiple customer. So suppose he has customer 1 and he has customer 2. Okay. Now what is happening here at the PE level, we'll go and enable some sort of VRF, virtual routing forwarding instance. Now what this VRF will do, that different customers, although those customers, they are using same address space, but still because we are using VRF, they will be separated. So that's one of the very important aspect we have with layer 3 VPN, because they are using the VRF. And with help of VRF, the PE is able to segregate same address space in between different customer 1, customer 2. Okay, so that's one of the very interesting aspect of layer 3 VPN. Second, very important thing here is that exchange the customer routing information. Now, how they are doing the exchange, we'll come to know that we are going to use MP BGP, and then we are going to use VPN v4. So in between to customer and PE to other PE, you'll find that you are going to enable BGP, and then they are going to form some sort of, you can think there's some sort of private network for each customer. And with respect to BGP. All right, what is VRF? Again, I told you that VRF is nothing, but you can go and segregate different routings. You can create instance of routing, is something like routing virtualization. Correct. So you may have one global table, but inside that you can create multiple VRF or multiple segregated routes for that particular customer. Now, suppose if you are not using label switching, and if you go and enable VRF without MPLS, you can see that if you go and enable the VRF and you're not using the label switching or tag switching, then that terminology is termed as a VRF light. But anyways, for routing optimization, we are going to use MPLS. But again, if you go and check only the enterprise network, so few of the customer, they are still enabling a VRF just to segregate their address space, just to segregate their routing space. Okay, great. So this is the overall topology lab diagram that we are going to discuss in the upcoming section. Step by step, I'll go and configure all the devices. We'll see each and everything. We'll see the level, we'll see the transport level, VPN level, etc. So everything we are going to discuss in the upcoming section. Before starting the lab sections, we have a few more questions. Let us discuss these questions, and in the next section, we'll go and start building our lab. So question number 22 here, you can see that which protocol is used between Ps. We know that we have P, provider edge, and these provider edge, obviously we are going to run MPBGP inside these provider edge, because these PEs, they are going to connect with the CE. So different customer edge, they are going to terminate it at PE, and PE has to enable the address family that is known as a VPN v4. So we have to go inside BGP and we have to enable address family VPN v4 in between the Ps. And in the lab section, you'll find that these Ps in our lab, they are part of same autonomous system. That means they are running iBGP. And then there are some other terms that we are going to use, that how we are going to exchange the route from CE to PE or vice versa. Okay, so one domain we have where we are not enabling the MPLS, and one domain we have where we have the MPLS, where we have the labels, or where we have the tagged routing table. Means you have the routing entries with the labels, correct? So the answer for question number 22 is that the address family is a VPN v4 that we want to enable. Now question number 23 is connected with 22, that what are the commands? So I'm going to show you the command, and let me quickly show you the diagram first. So here you can see this is our lab diagram where you have the PE provider edge, where you have the provider edge, and in between these provider edge, we are going to run the BGP. The address family should be VPN v4, and how we are going to enable. So here you can see, first of all, we are enabling the BGP in between these PE. So first of all, we have normal BGP relationship as iBGP relationship. So these commands we are very much familiar. We have done in our previous sections in the BGP section. But when we are talking about the address family VPN v4, here you can see that we are enabling VPN v4 address family, and for R1 this loopback is my neighbor. For R3 or PE3, as per our diagram, this loopback address is the neighbor. So neighbor 111 activate, and then we are doing the send community extend. Now why we are using this community extend? So let's see. Question number 24. What is the use of extended community? Why would you activate VPN v4 capabilities with iBGP pair? And what are to command, or what are the commands to activate a VPN v4 feature? So very much we have addressed question number 26, because you have seen the configuration. We have to go there and activate it. Once you are activating, you should understand about the configuration related to community extend. So now in upcoming few slides, we are going to discuss one very important concept related to tagging the routes to make it unique. So we are going to discuss about two terms. One is route distinguisher, other one is route target. So suppose if you have any IPv4 route, and if you want to make this unique, and again this route distinguisher is locally significant, so you can go here and do some sort of tagging. So you can go and use the tagging with the route, and this route will become means that's why this marking is something known as route distinguisher. So you can see that VPN v4 route, how it look like. They have the RD plus the prefix. Okay, so your VPN v4 routes having two component, first of all the prefix and then the RD. Now this is part one, that you're marking the route. But what about you want to import or export? Means you want to send to the sea, or you are taking from the sea. What about that? That I will show you in the next slide. Okay, so RD is something that we are making the routes unique, and obviously the labels will be there. MPLS VPN labels will be there. Actually, there are two different type of label, and you should understand at this point of time. Let me clean the stuff here. So we know that whenever you are sending the routes, you are putting some sort of tag or label, and we know that the PE devices, they are imposing the tags and sending to the next hop, next hop, next hop, next hop. Correct. Now, important thing here is this, that when we have two tag, That means when you are talking about VPN v4, I should write VPN v4. You can understand this is VPN version 4. So when we are talking about VPN v4 and MPLS together, how these tags are looking. So here you can see the transport. So you may have payload. Up to here we have the payload. But after that, you can see that you have VPN v4 label. That's your RD. And then you have the transport label. Okay, so which customer VPN will tell, VPN level will tell that which customer, and the transport level will tell which PE, correct? Because PE has to send the route to the CE, and that's the relation. It's actually very, very important. You should mark it, these labels. Transport label is for PE, VPN label is for CE. Now, second very important thing here, so that's the tagging here. You can see that you can use ASN colon NN or IP address colon NN, and I'm going to show you this in the lab section, so you will understand more and more how we can create it, how we can mark it. But second very important point we have here is the route target, RT. Okay, route target is something which has the significance when you are importing and exporting the routes. Okay. So this is 8-byte field. You can check RFC 4360 for more information. This is part of BGP extended community, and how this route target is working. So we'll see that this route target is working when we are importing and exporting the routes. So when you are at the PE level and you want to exchange the route with the CEs, so here you can see that when you are using the keyword called export, that means you are sending the route from VRF to BGP. When we are using the keyword called import, that means from BGP to VRF. Okay, and what exactly BGP to VRF, VRF to BGP? Again, you will understand this in the upcoming section. Okay, so what we have done here that we have answered few very, very important questions here, that how to enable VPN v4. What does it mean by RD, route distinguisher? What does it mean by RT? RT is there to import, export the route. RD, route distinguisher, is there to label, to put the marking over the route. And this payload information, it's very, very important. Okay, so how we can signify the CE, how we can signify the P, each and everything we have discussed in this particular section. All right, so let's stop here. In next section onwards, we will start building our lab. Let us start the lab configuration. What we are going to do, that we are going to build our lab configuration step by step. So first of all, I will go to the backbone. So we have the backbone here, and we'll do the configuration related to the PE1, PE2, that's PE3 here in our nomenclature naming convention, and then we have provider router as well. So you have PE, so different PEs, and then we have one assigned as a P. Now what we are doing here is that for the PE router, so for the MPLS backbone, we are going to run OSPF as IGP, and in between these PE devices, we are going to form the BGP relationship, and we want to enable VPN v4 address family. Okay, so let's do that first thing first. And again, you will see in the upcoming section, we have to do the routing in between PE to CE. Somewhere you'll find that I enable OSPF, somewhere we are going to run EIGRP, somewhere you will find BGP, somewhere you will find RIP. Okay, but we are going to do the configuration slowly, step by step. So first of all, let's focus on the lab topology devices. Those are R1, R2, and R3. We'll go and do the configuration on R1, R2, R3, and slowly we are going to move our configuration, and we'll go to other devices as well. All right, so let me go and start R1. In R1, so this is the R1, and safely I can go here and enable the OSPF over all the interfaces, or at least the interfaces that is facing towards the core MPLS network. All right, for sake of simplicity, I can go to router OSPF1 and then I can use 000, means I am advertising everything inside area 0. So for example, so this is my configuration on one of the router, that is the PE. Then we'll go to provider router. Oops. And I should configure OSPF and then the network configuration. And then I'll go to R3, that is other PE. And here also we can do the configuration related to OSPF. So OSPF1 and the network this. Now once we have this IGP running, and you should go and verify that you have your OSPF neighbors, that should come up. Still they are in some excess state, loading to full that we wanted. All right, and then you can go and check show IP route related to OSPF. You should get the routes that is coming from router number 3 actually. The loopback 3.3.3.3. So I can see here that in between R1 and R2 there is no problem, and R3, let's see, should have correct IP configuration and everything. So I can see one of the interfaces down here. We'll go here and make this no shutdown. I'll come back here. I should see loopback 3333 as well in a while. Now once we have our IGP running, then I'll go and enable the BGP. So we'll do the BGP configuration in between the P's, correct? Because our provider router, that is router number 2, is BGP free core, okay? And meanwhile, should come also, I can't see that it is coming up. That means that we have some network issue. I can see now that OSPF is loading to full. And if it's so, after convergence, this router should receive 33. Okay, so that's okay. Now let's do the BGP related configuration. So I can go here to router BGP. The AS number we are going to use here is 100. And once we are inside the BGP, then what BGP related configuration we want to do. So we can go here and we should form the IBGP neighbor relationship in between here. So for that IBGP relationship, what we can do, neighbor 3333 remote, remote AS, and there also I'm going to put this neighbor as a inside AS 100, correct? And again neighbor 33333 update source loopback. You know, everywhere we have created loopback 1, correct? Now we can go here, router BGP the 100, its neighbor is 1111, and the remote AS is 100 because we're going to form IBGP relationship in between. Update source loopback 1, and you should go and check show IPBGP summary. I can see here that you can see here that we have this neighbor relationship up and running. Now this is one part. The other part, that we want to enable the address family with respect to VPN v4. So here you can see that we have VPN v4 address family, and once we have address family VPN v4, then for this we want to activate the neighbor, that is 333, activate. Let's see that what options we have. So neighbor, you can see that we have activate option. We can go and activate this. And then we want to send the extended community. Now, here you can see that the topology for this has been changed to IPv4. Great. Now, next, what we want to do here, that my neighbor, and we are going to configure RD, route distinguisher, and route target. So those extended community also we can use here. Send community extended. Great. So R1 to R3 configuration is done. Here also I can go and use address family VPN v4, and when we have this, then we can go and give the neighbor 1111, activate, and then neighbor 1111, send the community extended. So this is the configuration we have related to R1 and R3. There are so many things that we are going to do still. So this is the baseline configuration that we have in between R1 and R2. Now next, what we want to do, that we'll go and follow our topology. According to that, we can do the routing related to one of the customer edge. Okay, so let's just stop here, and in upcoming session, I'll go and do the configuration related to customer edge and the P's. Okay. All right, so let's just stop here. We are going to do the configuration related to P to C for one site. One site means for one of the customer one. In this area, we are going to use OSPF. So the customer, they are running OSPF, and we'll see that how we are going to redistribute OSPF inside BGP and BGP inside OSPF. We'll see that how the routing is going to happen in between P to C, C to P. Likewise, here for customer one only, the other side of the customer, they may run any other protocol. We are going to take example with respect to RIP. So suppose this side customer one, they are running RIP protocol. So how we can go and do the redistribution related to RIP, that we are going to see. Now here, we are going to use the RD and RT. So we want to segregate the routes as well. So we are going to create the VRF, and then we are going to use the route tagging, route import and export, everything. Okay, so let's see that how we can perform these tasks one by one. First of all, I will go and do the configuration for this section, and then we'll go and continue on this section. So let's focus on the configuration for router number 4 and router number 1 in this topology. Let me go and open the lab device. So here we have router number 1 and we have router number 4. Since router number 4 configuration is easy, straightforward, I can go and do the configuration. Let's see that what interfaces we have in router number 4. And here you can see, let me see the reachability to the router number 1, that's the PE1, 10.1.14.1, it's reachable. Now, before doing any configuration here, I just wanted to go on router number 1, that's my PE, and we want to do the configuration. So we should have configuration related to VRF. So here I will go and create the VRF, IP VRF, say customer 1 or customer underscore 1, whatever suitable. Once we are here, I can go and give the RD. You can go and assign like this. I can go and give the IP address RD, correct? Now, once we have the RD, and let's see that you can see the format here for RD, and you should use that format. So IP address and NN. So let me go and use that .1, and then I can go and use any number we can use, correct? So I'll go and use here 101. Great, and let's continue and do the rest of the configuration. So let's continue and do this route target configuration. Route target. I want to export my uh, routes. So here we can go and do this export related to 1111 is my loop back 101, and then route target import the other side loop back address I'm taking here as an example. Okay, so we have the VRF configured here. Now, once we have the VRF, what I can do here is that we can go to the interface where we have the connection to the CE. So you can see the configuration here. This interface is connecting to the CE. So over this interface, we can go and use IP VRF forwarding customer one. And then you have to rewrite these IP addresses because now they're part of VRF. So again, we should go here and have the reachability. See, from the customer point of view, we are not doing anything. Customer as it is, they can run their own local protocol. They are doing whatever they have. There's no problem. But once this traffic will reach to P, we are doing the manipulation at the level of P. Now here I can go to router OSPF and I can do the router OSPF configuration. 114.0.0.0.255 area 0. Then I have one loop back 4444.0.0.0.0 area 0 like that. And that's very much done with the configuration related to CE. Now let's go and focus on PE. Okay, so we have our configuration related to RD and RT. We can go and give the MPLS level range as well if you want to specify our own range. So we can go and give. Great. So what we have done, basic configuration, we have created RD, RT. Then we have assigned the interface inside the VRF. Now next thing we have to do is the redistribution. Okay, so let's do it. So here I can go to router OSPF. We have to enable OSPF process related to our VRF. So we have our VRF. We know that VRF is customer one. And then once I am inside OSPF, I can redistribute BGP. We know that BGP is BGP 100 here and metric. So we are going to OSPF calling BGP so that BGP metric should be like OSPF. And we have discussed this in our redistribution section earlier. Great. Then what we can do that we have the network related to OSPF. That is nothing but 10.1.14.0 255 area 0. Now what we have done here is that we have redistributed BGP inside OSPF. Now if you go here and check show IP route, let's check the show IP route. Right, and if you go and check show IP OSPF neighbor, so it has his neighbor 14.1, and from 14.1 he should receive certain routes, should have the reachability, correct? All right, I'll come back to this because the idea here is this, that one point of CE should communicate to other point of C, correct? And we are going to discuss this. So I'll come back to this point. Now let's continue with PE configuration. What we have done, OSPF, we are calling a BGP like that. We should go inside BGP, and once we are inside the BGP, we should go to the address family. That let's see address family. What address family we have? We have IPv4 address family, and inside that we can go to the VRF. What's the name of the VRF? Customer one. Now inside BGP we can go and we have to go and redistribute OSPF, and we know that the VRF that we have is the customer one. Let's quickly check the VRF. Customer one, that's correct. Okay, so now what we have done the two-way redistribution, and you can see the configuration. Let me show you that. So what we have done, that inside OSPF we have called BGP, and inside BGP, inside address family IPv4, we are calling OSPF. Okay, so we are doing good configuration here, and there are some command that we should use it while doing this VPN v4 configuration related to our configuration. So here you can see show BGP, VPN v4, unicast, VRF, customer one. Let's see. So clearly you can see that the provider edge, they are getting the loopback 444, they are getting the IP over the, that is over the interface 10.1.14.0 subnet. Okay, and now let me go here and let's see that how much he's seeing. So still this is good. It's still the customer one network. So we'll go to other side. So what we have done the configuration for one side. So that means that this side is good. Now we'll do the configuration to this side, and once we do the configuration to this side, you will see that they will start exchanging the routes, because here also I have to go create VRFs and everything. Okay, so let's do it. Now I can go to router number 3, and let's working creating on VRFs. So here we are. What I want to do here also I want to create IPVRF, and that for customer 1, because customer 1 and customer 2 here also you have. For this RD I want to give 111, say 333, and here also I can give 101, because 101 for example is for customer 1. Then route target, I want to export my, so 101, and then route target import, I want to import 111 101. Then again I can go to gig interface 0/2, where we can go and do IPVRF forwarding related to customer 1, and then let's see, I think it has been removed. So then we have the IP here, IP address. That's IP, we know that what's the IP. This is 326. So 10.1.36.3, I should ping this. So if I go here to R6, and in R6, the routing protocol we want to use is a RIP routing protocol. So simply I can go here, router RIP version 2, no auto summary, and we have 10.1.36.0, and then we have one loopback as well, 6666. Great. So you can see that customer 1 other side, that's the router number 6, is configuration also done. Okay, let's go back to router number 3 where we are doing the configuration. So now what we want, inside RIP we want to call BGP, inside BGP we want to call RIP, means we want to do the redistribution. So I can go to router RIP, and here you'll see that how we can do the configuration. I can go to the address family IPv4 VRF, that is customer 1 redistribute BGP. And for BGP, what we can do, we can use the metric, correct? First of all, give the AS number and the metric. I'll give metric as 4. Done. And then I should go to router BGP, but before going there, should advertise the network as well. 10 dot. Anyways, the RIP is going to do the summarization. So I'll use 10.0.0, or maybe you can go and use 10.1.36.0. Now we can go to router BGP. This is very important configuration because this time we want to go inside the address family IPv4 VRF customer 1 redistribute RIP. Done. Now let's check. Show BGP VPN v4 unicast. That's the VRF is customer 1. Let's see. So now you can see that we are getting 444. Remember, 444 is coming from the customer 1 from other side, and he's doing 666 as well, 10.1.14 as well. So that means that if we go to router number 6, and if you go here and do show IP route, should see 444. See, 444 is coming from far end. And if you go to router number 1, sorry, if you go to router number 4, correct? Show IP route. See, nothing was coming earlier. Now you can see that he's knowing 6 network. He's knowing 36 network. And you can see that metric that we have used. So clearly we can see that end-to-end communication is happening between these two routers. That means that our configuration, import, export, everything is working perfectly fine. All right, so this way we can do, so you can see here, this is actually MPLS end-to-end configuration. All right, so let's just stop here. In this section, we are going to do the configuration for customer number 2. Now for customer number 2, we are going to use different routing protocols. Here we are going to use EIGRP. So within the AS, you'll find that we have within the autonomous system, because EIGRP using autonomous system. So within the autonomous system, you'll find that we are going to run EIGRP with AS15. And here in this portion, we want to use BGP. So here I will go and enable AS, that's a BGP 200, and in between AS 200 and AS 100, we'll go and form the relationship. All right, so let's do this thing, this configuration step by step. First of all, I will do the configuration to R1, this is router number 1 or PE1, and then R5, that's the customer 2 router number or one of the router. Okay, let me go back to the lab. So we are here in R1, and for R1, first of all, we need to do the VRF creation. So here I can go and create, say, customer number 2. Then we'll go and give the RD. So last time we have given 11111 This time I'll go give 1111 and then 102. then route, target, export. I want to export 111, then the label route 102, and then I want to import 333:102. Once we have that, we know that our gig 0/3 is going to connect with customer 2. So let's see the configuration here. Once you're over this interface, you can go and use IPVRF forwarding, correct? For customer 1, it's not customer 1 actually, this is for customer 2. And then IP address should be this. We can check this configuration. Interface gig 0/3 should be customer 2. That's right. Now we can go and do the verification related to this. I can go to router number 5 and we can ping. Let's see. The gateway is reachable. Yes. Great. And here what we want to do, here we want to enable router EIGRP15, no auto summary. Let's check the IP addresses here. So the IP address network is 10.1.15.0. Other network I can use 5.5.5.5. Okay, great. So this is configuration related to R5. Let's go back to router number 1 or PE1 and let's continue our configuration. So next thing what we want to do here is the redistribution. I can go to router EIGRP1. Here we are enabling EIGRP. And once we are inside router EIGRP1, we can go to the address family, IPv4 VRF customer 1, and then we can do the redistribution. Do the redistribution related to BGP, but the metric value should be EIGRP. And we know that we have the bandwidth, so I can go and give bandwidth. Delay should be less. Reliability should be 100%. Load should be less. MTU, it's up to us that what MTU we are giving. All right. So this is the redistribution. Once we have the redistribution, again, I can go and advertise the network. We have the network between this router and router number 5. So network we have, you can see 10.1.15. So I can go and give the network 10.1.15.0 and space and enter. Auto summary. Great. So we have done the configuration. That is again one part of configuration. Next, we should go. You can see that it is telling that you should give the autonomous system. So one line is missing here, that once we are here, so let me go back to this system one more time. You should give the autonomous system for the EIGRP. And we know that EIGRP autonomous system that we are advertising here is 15. Correct. So let's go back one step more here. Oops, we are here and it should give the autonomous system. So let's see that what options we have. All right, so we have done the redistribution here. So once we are here, and okay. Yeah, let's see. So router EIGRP1, then we can go to the address family IP v4 VRF customer. Actually, this should be customer 2 autonomous system. Here you can see 15. Like that, you can give, or you can give the autonomous system. So once I am inside here, I should give me option for autonomous system. Okay, so you can see it's not giving it. Like that, we can give the autonomous system, and then we can do rest of the configuration. But before doing that configuration, let's quickly see section EIGRP. And here you can see, okay, so entirely wrong configuration that I have done, because this is not customer 1, this should be customer number 2. But yeah, anyways, we know this. No router EIGRP1. Let's remove everything. EIGRP, let's see. Nothing is there. Now we can go to router EIGRP1. We can go to this address family. Then we can do the redistribution related to BGP. Correct. Great. And then I can give the network as well. And I can see here that the EIGRP is working and it's exchanging some of the route. What configuration CLI command to do the verification? So this time we can go and check the VPN v4 unicast, and the VRF is customer number 2. Let's see. Great. Show IP VRF. That's okay. I'll come back to this configuration. Let's continue our configuration to other side. To other side means let's do the configuration to PE number 2 and the router number 7. So router number 7, what configuration we have? BGP configuration, correct? Show IP interface brief, router BGP 200, and then what is his neighbor? So neighbor is, let's see the IP here. Start 3. So his neighbor is this, whose remote is going to be 100. I just want to redistribute my connected routes, and that's it. Okay, and redistribute connected means I'm not using network command, although we can go and use the network command to advertise my loopback and the interfaces, connected interfaces. Okay, so that's it. We have the configuration related to R7. Let's go and focus the configuration here inside this PE. So first of all, we want to create the RDs. Okay, and let's check section VRF. So here you can see that I can go and create VRF for customer 2, then RD. I can go and give the RD, say 3333, very much same, but only 102. Then route target, export. I want to export 3333:102, and then I want to import 1111:. So you can see the configuration is very much similar, only few things are changing now. Okay, we can go and check the interface key 0/3. I can see the IP here, so you can go back and assign this IP once it will get removed. So interface key 0/3, IP VRF forward the customer number 2, and then you can give this IP. Make sure that once you assign this IP, should be reachable from the customer. So we can go to the customer now and we'll ping this. You can see this is reachable. Great. So our RD and route target configuration done, verbs done. Now what we need to do here that we have to go and do the redistribution related to BGP. Now since we are using BGP here as a MPLS core and a redistribution point for P and C, so we can go to BGP 100 and inside address family we have to play around. Okay, so before doing that we should have the configuration related to P to C with respect to BGP. Okay, so let's do that. Address family IPv4 and what is that, VRF customer 2, correct? So first of all we'll go inside the customer number 2 and then who is my neighbor? My neighbor is 10.1.37.7 whose remote AS is 200, and this neighbor I just want to activate. So now we can see that neighbor is up. We can go and verify BGP summary. I can see the neighbor is up. Show IP route. Now before doing any further enhancement here, what we can do here is that we can go and check show BGP VPN v4 unicast for VRF customer number 2. Let's see what we have. So he is getting 777.37. At the moment I can see that he is not getting 555. And let's go back here and check. Same configuration, big configuration, CLI verification commands. I can copy and paste here. Let's see customer 2. So good thing here is this, that I can see that one-way communication. That means that if we go to router number 5, and if we go and check show IP route, you can see that he is learning 777 means customer from other side, but he is actually not advertising his own network. So he should get 555 here. That is not. So one-way communication is happening actually in one direction, and we need to continue go and fix this. So what is happening here actually, that from here to here you have the route, but from here to here we don't have the routes advertised to customer to that end. All right, so what we are going to do here, I will go and continue this troubleshooting. Let's break here, and in the next section we'll go and check if we have any missing things, if we have any issues. Apart from that, what we'll do in the next section, that we'll go and do some verification as well, some CLI commands for verification. I will show you that. Okay, so let's stop here. In this section, we are going to discuss about the troubleshooting steps that we have. Apart from that, we have seen that in the previous section, we try to bring up, or we try to reach to one of the subnet, and you see that one-way communication was there, but 5555 was not going advertising inside customer number 2. So we are going to troubleshoot that as well. Now, while doing the MPLS related troubleshooting, we should go and verify the VRF configuration. The VRF is assigned to correct interfaces or not, enabling the VRF related routing, the VPN v4 related configuration, redistribution, finally the redistribution related to VPN v4. Redistribution means, so what does it mean? It means that when you have the CE routers, although CE routers, they are running their own IGP, and then when they are going to do the exchange, routing exchange with PE routers, you should have the redistribution configured at PE. So suppose if you do the redistribution one way, so we will see only one way traffic is coming, the return traffic will not go and reach, correct? So we have to go and check the redistribution. Basically, since we are running BGP here, and remember BGP peers, so we have two different PE, PE1 and PE2. Both are IBGP neighbors. Now, since you have two protocol here, one is related to CE, one is related to BGP. Make sure that inside CE we are redistributing BGP. Make sure that inside BGP we are redistributing CE routes. And we have taken example related to almost all the routes. Like we have taken example related to OSPF, RIP, EIGRP and BGP. Okay. Now there are some additional steps that we can go and verify the VRF. So VRF configuration, so IPVRF, show IPVRF detail. We want to go and check the route import export. You can go and use show IP route related to that particular customer VRF. Then we are using this command. This is actually very important command. Show BGP VPN v4 unicast VRF with related to customer 1 or customer 2. Correct. Again, we have a debug commands. We can go and check more on BGP VPN v4 unicast related commands. We can go and check the MPLS are enabled over the interfaces or not. If you want to do the label related troubleshooting, so you can go and check show IP BGP VPN v4, the RD name and the labels related to that. Again, we can go and check the show IP BGP VPN v4 unicast VRF customer labels and their detail. Great. So this is the way, these are the very important verification commands that we have handy. Let's go back and let's check the router number 2, that do we have the configuration related to redistribution. Actually, we should go to PER1 and let's check this. This is one of the very important verification commands. Show BGP VPN v4, BGP VPN v4 unicast VRF customer 1. If we go and press enter, obviously it will show you all the VRF. So if you go and type okay unicast all, we want to see all the VRF information, you can use this all command. So here you can see that related to customer number 2, we are focusing on customer number 2. You can see that customer number 2 can see 777 and different RDs are there. Let's focus on customer number 2. We are not seeing that. Okay, let's go and check the redistribution. First of all, we'll go and check inside EIGRP, are we calling RIP? Inside EIGRP, are we calling BGP? So router EIGRP, we are redistributing BGP. That's 100% correct. Likewise, we can go and check the BGP. Inside BGP, are we calling EIGRP? So we are inside BGP, you can see BGP 100. We are calling customer 1 OSPF, but seems we are not redistributing here the EIGRP route. So we can go to router BGP 100, should go to address family IPv4 VRF customer number 2, redistribute the EIGRP. whose autonomous system is 15. And again, you can go and assign the metric. Leave the default metric at this point of time. And now if you go and check show BGP VPN v4, unicast VRF is customer number 2. Sweet. So now you can see that 555 is coming into the picture. And now if you go here and check show IP route, you can see now that 555 is appearing in the routing table. Okay, and since we haven't given any specific metric, so it is taking the default metric, but we can go and assign some metric. All right, so we have completed our MPLS related lab. Let's just stop here. Hello everyone, welcome to my CCI Enterprise course. In this course, you will learn all the technology related to your CCI Enterprise journey. And in case if you are looking for the actual lab type of scenario and the solution, then you can reach out. You can send me email ratnesh721kumar721, that is here. And then I will send you that detailed info that how my students, they are preparing for their actual lab training. It will be almost similar that what you will expect in the exam. You can practice. I will help you. I will guide you for 1 month to clear this exam. I will help you step by step how to drill down um, the solution, drill down the technology into small pieces, and I will help you to pass your exam in first attempt. So go for this course. This will be a good place where you can learn the technology. But if you are serious about the CCI lab exam, then you can drop me an email and you can get the detailed info. All right, so let me stop this video, and if you watch this video, you can simply contact me and you can get the information related to the new update that we have in the CCI Enterprise Lab.